This is section 1.3, part C, measuring spread. We're going to be working with the standard deviation. The five-number summary is not the most common numerical description of a distribution. That distinction belongs to the combination of the mean to the measure of center and the standard deviation to the measure of spread. The standard deviation and its close relative, the variance, measure spread by looking at how far the observations are from their mean. Investigating spread around the mean. So a group of elementary school children were asked how many pets they have. Here are their responses, arranged from the lowest to the highest. We need to find the mean number of pets for this group of children. So remember, to find the mean, you're going to add all the values together and then divide by the number of observations. So when we add them all together, there are 9 children. We're going to divide that by 9, and the average is 5 pets per child. What does this mean tell us? This means if we take all the pets from all the children and divide them up equally between the children, then each child would have 5 pets. So below is a dot plot of the data with the mean clearly marked. The data value of 1 is 4 units below the mean. The value of 3 is 2 units below. 4 is 1 unit below. 7 is 2 above. 8 is 3 above. And 9 is 4 above. We say that its deviation from the mean, each one of these deviations, is however many units away it is. So the value of x is equal to 1 has a deviation of negative 4. So what would be the deviation value for 7? Its deviation would be 2 because it is 2 above the mean. So below is a table that shows each observation and how far the observation deviates from the mean. So you take your observation, you subtract your mean, and that would tell you your deviation. If we add up all these deviations together, we should get a sum of 0. This is because the mean should be a balancing point of all the data points in the observation. Since the sum of the deviations from the mean will be 0 for any set of data, we need another way to calculate spread around the mean. We need to fix the problem of the positive and the negative deviations canceling out. To do this, we're just going to square each deviation. So we have our observation. We found our deviation by taking our observation minus the mean. Now these are going to give us positive and negative values. To get rid of that, we're going to square those. So negative 4 squared gives us 16, negative 2 squared gives us 4, so on and so forth. Then we're going to find the sum of these values. From the sum of the square deviations, we find the average square deviation, which is called the variance. Now, average is in quotes because it's not the actual average. When you divide it, you're going to divide it by n minus 1. So the number of observations minus 1. We're going to add all those square deviations together and divide by n minus 1, and this will tell us our variance. In this case, our variance is going to be 6.5. Because we squared all those deviations, our units are squared pets. Now this doesn't make any sense for our problem. So to get rid of that squared pets, we will take the square root of both sides so that we will just end up with the unit of pets. So our standard deviation is equal to the square root of the average squared deviation. So if we take the square root of 6.5, we're going to get 2.55. So this 2.55 is roughly the average distance of the values in the data set from the mean. So this is telling you on average each data point is approximately 2.5 units away from the mean, which in this case our units are pets. So the standard deviation, which we're going to call S sub x, measures the average distance of the observations from their mean. It is calculated by finding the average of the squared distances and then taking the square root. This average squared distance is called the variance. And we show the variance by saying S sub x squared. because it is a squared unit. To find s sub x squared, this is equal to the sum of your observations minus your x bar, remember your x bar is your mean, squared, divided by n minus 1. So the standard deviation formula is the square root of the sum of your observation minus your mean squared all over n minus 1. So when you're finding the standard deviation for n observations, the first thing you're going to do is find the distance of each observation from the mean and square those distances. We're going to average those distances by dividing by the sum of n minus 1, and then you'll take the square root of that value. Many calculators report two standard deviations, giving you a choice of dividing by n or by n minus 1. The standard deviation for an entire population is going to be sigma sub x, and that's found by dividing by n. While the standard deviation of a sample of a population, s sub x, is found by dividing by n minus 1. We must first decide if we are examining an entire population or if you're just examining a sample of a population. One way to tell is to look at the mean. If we're talking about an entire population, the mean is denoted as sigma, while the mean of a sample population is denoted x bar. So if you have sigma for your standard deviation, you're going to use sigma sub x. And if you have x bar, the standard deviation you're going to want to use is s sub x. More important than the details of the calculating s sub x are the properties that determine the usefulness of the standard deviation. S sub x measures the spread about the mean and should be used only when the mean is chosen as the measure of center. So if our data is very skewed one direction or the other, or has very large outliers, it will probably not be appropriate to use S sub x because you would be using median instead of mean. S sub x is always greater than or equal to 0. If S sub x is equal to 0, there is no variability. This is only going to happen when all the observations are the exact same value. Otherwise, your S sub x will always be greater than 0. As the observations become more spread out from the mean, S sub x will get larger. S sub x has the same units of measurement as the original observations. So when we were talking about pets, our standard deviation was pets. If we're talking about metabolic rate in calories, then we would have the same units in our standard deviation. Like the mean, your x bar, S sub x is not resistant. So a few outliers can make S sub x very large. Now the good news is you don't always have to do these by hand. You can calculate the standard deviation on your calculator. Let's go back to the problem about the North Carolina workers, how long it takes them to travel to work, and they took a sample of 15 workers. So the first thing we're going to do is input the data into list 1. Then you're going to press stat, go over to calc, and you're going to choose option 1, which is 1 vars stat. And you're going to press enter. Now press second 1, which will get you select your list 1, and hit enter. And if you press the down arrows, it'll show you all the one value statistics for North Carolina. So with this data, you should have your x bar is 22.46 repeating, which tells us our mean for the sample. If you notice, we have an S sub x and we have a sigma x. Sigma x would be if we were using the entire population, but since this is a sample, we're going to use S sub x, so our standard deviation is 15.23 minutes. So on average, the observations vary from the mean by about 15 minutes. We also have in this the minimum, the Q1, the median, the Q3, and the maximum. So we do have our 5-number summary listed here as well. The median and the IQR are usually better than the mean and standard deviation for describing a skewed distribution or a distribution with strong outliers. We're going to use x bar and S sub x only for reasonably symmetric distributions that do not have outliers. You need to be cautious. Remember that a graph gives the best overall picture of a distribution. Numerical measures of center and spread report specific facts about a distribution, but they do not describe its entire shape. Numerical summaries do not highlight the presence of multiple peaks or clusters, for example, so make sure you always plot your data. For their final project, a group of AP Statistics students investigated their belief that females text more than males. They asked a random sample of students from their school to record the number of text messages sent and received over a 2-day period. Here are their data. What conclusions should the students draw? Give appropriate evidence to support your answer. So the first thing we should do is state. This is going to be a 4-step problem. So do the data give convincing evidence that females text more than males? You're stating what you're trying to solve. Next, we need to come up with a plan. We will begin by making side-by-side box plots. Then we will calculate one variable statistics. Finally, we will compare shape, center, spread, and outliers of the two distributions. So then we're actually going to do these things. So if we go to the do, if we have box plots, remember you can make those box plots on your calculator. You can tell from the box plot that this data is going to be skewed to the right, and for males there are going to be outliers. We also calculated the information. We have the x-bar and the standard deviation. We also have the minimum, Q1, median, Q3, and max, and the IQR for all of the data. Due to the strong skewness and outliers, we will use the median and IQR instead of the mean and standard deviation when discussing the center and the spread. So then we actually need to discuss, we're still in the do part, what we notice about these graphs. So the shape, both distributions are highly skewed to the left. Because they are skewed, we're going to talk about that IQR. So on the spread, there's more variability in texting amongst females than males. The IQR for females is 157, and that's about twice the IQR for the males, which is 77. For the center, on average, females text more than males. The median number of texts for females is 107, which is about 4 times as high as the males, which is 28. In fact, the median for females is above the 3rd quartile for the males. This indicates that over 75% of the males text less than the typical, which is the median, female. Note we did not put the average female because that would be indicating the mean instead of the median. Outliers. There are 2 outliers in the male distribution, students who reported 213 and 214 texts in 2 days. The female distribution does not have outliers. So we need to conclude. The data from this survey project give very strong evidence to support the students' belief that females text more than males. Females sent and received a median of 107 texts over a 2-day period, which exceeds the number of texts reported by over 75% of the males. A tip for when you're taking your AP exam: use statistical terms carefully and correctly on the AP exam. Don't say mean if you really mean the median. Range is a single number, so are Q1, Q3, and IQR. They do not have units. Avoid colloquial use of language like the outlier skews the mean. Skewed is a shape, it is not a verb. If you misuse a term, expect to lose some credit. So the height in inches of 5 starters on the basketball team are 67, 72, 76, 76, and 84. Find and interpret the mean, and you need to show your work. If it says to show your work, you do have to do the calculation by hand and not use the calculator. So to find the mean, remember you're going to add all of the observations together and divide by the number of observations, which in this case are 5, and you should get 75. This means if the total of all the heights was the same for all 5 players, each player would be 75 inches tall. Make a table that shows for each value its deviation from the mean and its square deviation from the mean. So remember, to find the deviation, you're going to take the observation and subtract the mean. And then your square deviation, you're just going to take each of those values and square them. Show how to calculate the variance and standard deviation from the values in your table. Your total squared deviation is 156. So remember, to find your variance, you're going to take your total square deviation and divide it by n minus 1. In this case, this is going to be 156 divided by 5 minus 1, or dividing by 4. And our variance is going to be 39 square inches. To find the standard deviation, you're just going to take the square root of the variance, and the square root of 39 is 6.24 inches. So this means on average, each of those players is around 6.24 inches away from the mean height of the players. So if we're interpreting the mean of that standard deviation, like we said, the players' heights vary about 6.24 inches from the mean height of 75 inches on average.